So in this video, we're going to go over the problems that are in your Unit 5 test review. So in this first question, it asks what data model can be used to represent the data in the following tables. So how do you look at a table and determine whether you have a linear, quadratic, or exponential function? Well, in this first table, notice that every time the y values have a change of plus 5, right? Every single y value, if we look at what's happening, it's going up by 5. So this kind of constant rate of change happens when you have a linear function. Let's look at the next table. If we look at how the y values are changing, notice that they go down by 1, then up by 1, then up 3, and then up 5. So it's not a constant rate of change, but we look at how much the rate of change is changing. So notice that this goes up 2, then this goes up 2, and it goes up 2. So this is something called the second difference. When the second difference like that is the same, we have a quadratic function. In the third table, we don't have the same thing being added or subtracted, but if we look at it, if we do 5 divided by 25, that gives us 0.2. So every time the values in this table are being multiplied by the same number. If you check this, notice that they're always being multiplied by 0.2. And that is something that happens when we have an exponential function. So by looking at the table of values, you can tell whether you have a linear, quadratic, or exponential function. You can also graph these tables in Desmos or in your calculator and look at the shape of the curve or the line to figure out what kind of function you have. So in this problem, it says that the table and graph represent the amount of time students in a class studied for the test and their test scores. Create a linear model to best fit this data. So there's two ways to do these problems. You may choose to use Desmos or your calculator. I'm going to show you both ways. So if you go to your calculator, you're going to click on Stat and then hit Enter on Edit. And then in L1, we're going to enter all of the hours studied, and we're going to enter all of these test scores into L2. So this is going to be L1 and this is going to be L2. If you're doing this in Desmos, you're going to click plus table and then you're going to enter your values here. So I'm going to pause the video while you go ahead and enter these values. So now if you're doing this on the calculator, you're going to click Stat and then arrow right to Calculate and choose option 4, which is Linear Regression. So keep hitting Enter until Calculate is highlighted, and then it's going to give you the values that we need to write our equation. So our equation will be y equals 5.43x plus 76.41. Okay. If you're in Desmos, once you have your table, you're going to type y1 is approximately mx1 plus b, and then if you scroll down to parameters, it gives you those values that you need to plug into your equation. So now let's try problem 3. It says that a company began producing an environmentally safe household cleaner. The table below shows the number of units of the product sold over the first 6 years it was on the market. Use a quadratic regression model to figure out how many units the company will sell 9 years after it opened. So what we're going to do is we're going to do the number of years as our L1 and the units sold as L2. If you're in Desmos, we're going to call this left column X and we're going to call the right column Y. So go ahead and clear out what you have, right? If you're in Desmos, click the X's. If you're in your calculator, just go to Stat, Edit, and then go up until the title of the column is highlighted, click Clear, and then Enter. Do the same thing in L2. Highlight L2, click Clear, and then Enter. And I'm going to pause the video while you go ahead and enter these values. Okay, so notice in this problem we want a quadratic regression. So if you're on your calculator, you're going to click Stat, go to Calculate, and then you're going to choose option 5, which is Quadratic Regression. Now keep hitting Enter until Calculate is highlighted, and then click Enter again. So it gives us the values of a, b, and c we can use to write our quadratic equation, which is y equals 0.82x squared minus 0.75x plus 1. If you're in Desmos, you're going to go to row 2 after you typed in your table and do y1 is approximately ax1 squared plus bx1 plus c. Okay, and if you scroll down to parameters, it gives you the values of a, b, and c to write your equation. Notice in this problem, it wants us to figure out how many units the company will sell 9 years after it opened. So I'm going to go ahead and plug in 9 for x, and then I'm going to use that to figure out how many units they will sell 9 years after they opened. So if I just go ahead and type this in my calculator now, I'm going to do 0.82 times 9 squared, and then minus 0.75 times 9, and then do plus 1. And so that gives me 60.67. So since this rounds to the nearest whole number, I'm going to round that to about 61. And this is in thousands, so they're going to sell about 61,000 units. Okay, so now let's try this problem. It says that a company needs to earn $500,000 in sales before they can appear on Shark Tank. Their annual sales can be modeled by the function y equals 2 times 3 to the x, where x represents the number of weeks they are in operation. How many weeks will it take the company to earn enough money to appear on Shark Tank? So this problem kind of gives us an endpoint, right? We want to be at $500,000, and we want that to equal 2 times 3 to the x, which is our income function. So this is an exponential equation we need to solve, kind of like the ones we did back in Unit 4. So remember, our strategy is to get that exponential term by itself. So I'm going to go ahead and divide both sides of this equation by 2. So I get 250,000 equals, and then these 2's cancel, 3 to the x. Now I can take the log of both sides, and that's going to allow me to get that x out of the exponent. So I have this equals a log of 3 to the x. So remember, I can use the power property to bring that x down in front. So I have the log of 250,000 equals x log 3. So now to solve this, I'm going to need to divide both sides by the log of 3. So that's going to give me the log of 250,000 divided by the log of 3 equals x. So now I can just use my calculator to solve for x. So I have log of 250,000, and then I'm going to divide that by the log of 3. So when I do that, that gives me 11.3. So I have x equals 11.3. So it's going to take them about 11 weeks in order to earn enough money to appear on Shark Tank. Okay, so now let's use a graphing calculator to solve this problem. It wants us to write a linear regression model. So you see in these regression questions, it's really important to pay attention to what kind of model that they're asking for. So remember to clear everything you have already in your calculator. It doesn't matter if you're using Desmos or your calculator, just clear everything out and go ahead and enter this table into your calculator. So now that you have these values entered, if you're on your calculator, you're going to click Stat, arrow to calculate, choose option 4, which is linear regression, hit enter, keep hitting enter until calculate is highlighted, and then it gives you the values we need to write the equation. So we're going to have y equals negative 1.48x plus 3.54. If you're in Desmos, remember you're going to go to row 2 and type y1 is approximately mx1 plus b. If we scroll down to parameters, it gives us the same values. So in this problem, it says the table represents the sales in millions of a company. Write a linear regression model and use it to predict the company's sales 6 weeks after they are open. So once again, we need a linear model. So I'm just going to do this one on the calculator. I'm going to go ahead and clear what I have. And then I'm going to go ahead and enter these values into L1 and L2. So now that we have these values entered, we're going to click on Stat and then arrow to calculate. Choose option 4, which is linear regression, and then keep hitting enter. And then once we get this value, we can go ahead and write our equation. So we have y equals negative 1.79x plus 15.45. Okay, so now let's do number 7. It gives us a table of values and asks us to write an exponential regression model. So we're going to go ahead and go to Stat Edit, and we're going to clear what we have in L1 and L2. So if you're on Desmos, you can go ahead and exit out of everything and then click plus and then create a new table. So I'm going to pause the video while you go ahead and enter these values. So notice here we have an exponential regression. So what we're going to do is we're going to go to Stat, Calculate, and we're going to choose option 0, which is exponential regression. So you're going to hit enter and then keep hitting enter. And then when you're on Calculate, it gives you the values of A and B. So we have y equals 27.0 times 1.15 to the x, right? Because remember, when we're doing exponential, it's going to plug into y equals a times b to the x form. If we're in Desmos, we're going to type y1 is approximately a times b to the x1 power. And then in parameters, it gives us 29.7, and we have 1.14. So it's a little bit different than what we got with our TI calculator, and that's because regressions are an approximation. Okay, so sometimes there may be a little bit of a difference in the values that you get when you use your calculator or Desmos. But if you're in doubt, you just go back and double check your table and make sure that you entered everything correctly. Okay, so now let's try number 8. So number 8, I'm going to do on the graphing calculator. So we're going to do stat edit. I'm going to clear out L1 and L2. And once again, it's asking us for an exponential regression. So go ahead and enter these values into the table, and then we will work on the regression. So now that the values are all entered in, we're going to click on Stat and then arrow to calculate and then choose option 0 because it is asking us once again for an exponential regression. So we choose option 0 and then hit enter on calculate, and we can plug these values into y equals a times b to the x. So we have y equals 215.98 times 1.65 to the x. Okay, and that's our exponential regression model. So now in this problem, it gives us a table and asks us to write a quadratic function that best fits this data. So I'm just going to do this one on Desmos. So we can click plus and then do the table. And I'm going to go ahead and enter the values into the table. Okay, so now that we have everything in the table, we're going to do y1 is approximately ax1 squared, and then plus bx1, and then plus c. So now if we scroll down to parameters, it gives us the values of a, b, and c that we need to write our equation. So our equation is going to be y equals negative 0.26 x squared plus 22.59x plus 23.03. Okay, and that's our quadratic function. So now in number 10, it wants us to once again write a quadratic function. So this one I'm going to do on the TI. So our x values, remember, are going to go into L1 and our y values are going to go into L2. So remember, you go to Stat Edit and then go up and clear what is in L1 and go up and clear what is in L2. So I'm going to pause the video as you go ahead and enter these values into your table. Okay, so now that we have our values all entered here, we're going to click Stat and then arrow to calculate. We're going to choose option 5, which is Quadratic Regression. Hit Enter. And then keep hitting enter and then on calculate, you hit enter again. And so we have y equals 0.012 x squared minus 0.31x, and then plus, and then this is negative 0.00048. Okay, so that plus, we can actually change it to a minus and just leave that as a minus sign. So that is going to be the quadratic function that best fits this data.